Before there was light, before Earth had a name, before anything we know had ever been born, there was only a drifting cloud, a slow shapeless gathering of dust and gas, floating in the quiet nothing between stars. It moved without a destination. No sound, no warmth, just waiting. Then something changed. No one knows. Maybe a nearby star died and its shockwave stirred the cloud. Maybe gravity, slowly and silently, pulled one edge tighter than the rest. But whatever it was, it began to fall inward. The centre grew heavy, and as it collapsed, pressure built where there had been none. What was once still began to spin. At the very heart of this collapsing cloud, temperatures climbed. Particles slammed into each other with more and more force, and then, in one impossible moment, fusion began. The very first light of our sun burst into being, not loud, not visible from any nearby world, because there were no worlds, but real. Our star was born from nothing but weight, heat, and time. Around it the rest of the cloud kept spinning. Not gently, not smoothly. It was chaos. Fragments smashed together and shattered apart, some clumped and grew, others vanished in collisions. For millions of years there was no peace. Just spiralling motion, fire, rubble, gravity sculpting things not with hands but with pressure and chance. This is how our planets were made, not from design, not from science, but from violence. Mercury, Venus, Earth, Mars, all carved from collisions. Broken pieces of failed worlds still float between Mars and Jupiter, where a planet almost happened, but did not. The asteroid belt is the graveyard of a dream that never came true. Further out, Jupiter became too large. It swallowed light gases like a greedy child, pulling them in until it was massive enough to shape the fates of its siblings. Its gravity pushed other planets off course. It might have even protected Earth from too many incoming comets, or doomed others with its pull. We don't fully know. Saturn followed, then Uranus, Neptune, each forming not in neat order, but by a shifting dance. Some scientists believe they swapped places during their growth. Imagine that. Entire planets changing homes in a system still being born. And somehow, out of all this, a balance emerged. Orbits settled, light bathed new surfaces, moons found their partners, and one small blue world, third from the centre, began to cool. But here is where it becomes stranger. Our sun is alone. Most stars are born with siblings, binary pairs, or even trios. Yet our system has just one. Did we once have a twin star? Did something steal it? Did we form in isolation when almost no others do? The math says we are the exception, not the rule. Even more curious is the debris that remains. All that leftover material, the comets, the icy edges, the distant dwarfs that barely orbit within reach. And then, the missing things. Gaps in the system where something once might have circled, empty lanes between the orbits, clues written in gravity. There's something off about how much mass we have, and how much seems to be gone. The solar system was never designed to be quiet. Its balance is not perfect. It is a story of chance, of heat and dust choosing where to fall, and we are the result. Every stone, every wave, every breath we take, shaped by that storm long before Earth was even solid. And now, when we look up, we see calm skies, but that calm was earned. It is not where we began, it is only where we are, for now. If we'd been born elsewhere, if that collapsing cloud had spun just a little differently, would we even be here? Or are we just one quiet accident in a universe full of noise still waiting to become stars? Mercury does not spin like the others. It moves with a rhythm that feels off, like a clock with a missing beat. You might think it turns once every trip around the sun, always keeping the same face forward, like our moon does with Earth, but it does not. Instead, Mercury spins exactly 3 times for every 2 orbits. A 3.2 dance, not locked, but caught. Because of this strange motion, one day on Mercury, one sunrise to the next, lasts 26 Earth days, almost half a year. That means if you stood on its surface, you would watch the sun rise slowly, painfully slowly. Then it would stop, hang in the sky, and eventually reverse. Not because the sun changed, but because Mercury's motion pulled the sky backwards. There is no place in our solar system where time feels more broken. One side of the planet is gripped by brutal heat, where sunlight bakes the rocks to over 800 degrees Fahrenheit. The other side lies in shadow, so cold it could freeze metal. There is no wind to carry warmth, no atmosphere thick enough to soften the extremes. It is a world of two faces with no middle. For a long time, people thought Mercury didn't spin at all. Astronomers believed it was tidally locked, showing the same side to the sun forever. Their telescopes always caught the same craters, the same scars. It wasn't until the mid-1900s, when radar was bounced off the surface, that the truth came through. Mercury does spin, just not in a way anyone had guessed. Its orbit is not circular. It stretches and narrows, speeding up and slowing down, and the sun's gravity pulls hard, dragging Mercury's shape slightly out of the round. This tension, built over billions of years, created a balance, not quite locked, not quite free, a compromise written in physics. Mercury does not have moons, no rings, no clouds. It doesn't even hold much air. It is quiet, hard, alone, the smallest planet, the closest to the sun, and yet almost invisible. It reflects little light. Its surface is ancient and cratered, untouched by weather, unsoftened by time, and still it moves. Just not the way we expect. There's something humbling in that even here, so near to the sun, there is mystery. A planet that spins wrong, a place where a day lasts longer than a year, a world that feels pause between moments, as if it's waiting for something it cannot name. But what if its rhythm is not broken, just older than ours? What if its strange spin is a memory of the solar system before it calmed, before the planets found their orbits, before time was regular? And if Mercury remembers something, what else might it be trying to tell us? Venus shines the brightest in our night sky. It arrives in the early evening like a jewel near the horizon, glowing white, steady and calm. People call it the evening star, the morning star, a symbol of beauty. But if you could get closer, if you could step through that glowing veil, you would find something else entirely. The world beneath that light is not gentle. It is crushing. The air is thick enough to squash a human body flat. The surface is hotter than any oven on Earth, over 860 degrees Fahrenheit, hotter than Mercury, even though it's farther from the sun. Winds tear through the sky at hundreds of miles per hour. Sulfur clouds boil above endless plains of volcanic rock, and no sound escapes, not even echoes. Venus is quiet in a way that feels unnatural. But it wasn't always like this. That's the strange part. That's the sad part. Venus might once have been a sister to Earth, not just in size but in soul. A planet with blue oceans, with clouds that carried rain, with air that could be breathed, maybe even walked through. It might have had rivers, shallow seas, open skies. Scientists believe that for hundreds of millions of years Venus was not a furnace. It was mild, calm, the kind of place that could cradle something fragile. Not life maybe, not for sure, but potential. And then something changed, slowly at first. Then all at once, the oceans began to evaporate, steam thickened the atmosphere. Water vapour, a greenhouse gas, trapped heat. That heat caused more evaporation, more trapping. The cycle fed itself, growing hotter and faster until there was no more water left to hold things steady. The greenhouse effect ran wild, and Venus crossed a line it could never return from. Today, the clouds above Venus are made not of water, but sulfuric acid. They swirl in layers so dense, so reflective, they hide the surface completely. For decades, we didn't even know what lay below. Radar maps finally revealed a world of volcanoes and jagged ground, but we still haven't seen it with human eyes. We probably never will. What happened to the rain? Where did it go? Why did Venus fall while Earth remained? We don't fully know, but one clue hides in the air itself for deuterium, a heavy form of hydrogen. On Earth it's rare, on Venus it's everywhere, and that suggests the planet once held vast amounts of water, but the light hydrogen escaped. The heavier deuterium stayed behind. The ratio between them is a fingerprint, and that fingerprint says oceans long gone. The volcanoes are still there. Some of them might even be alive, not in the way we think of life, but in the way magma sometimes stirs deep below. We've seen hints of heat, maybe movement, but nothing firm. Venus doesn't give up its secrets easily. It hides them beneath layers of acid, pressure, and silence. Lightning flashes in its clouds too, brief, bright, and distant. But the thunder never reaches us. The air is too thick. The storm's too strange. Venus rumbles, but it does not speak. And yet there's a longing in the way it lingers near our skies. Earth and Venus are often called twins, nearly the same size, almost the same mass. But the resemblance ends there. One is blue, one is burning, one holds life, the other holds memory of what it could have been, of what it almost was. There's something deeply human about Venus, something tragic, something unfinished. It makes you wonder how thin the line is between balance and ruin, between a planet that breathes and one that chokes. Some scientists believe Venus could warn us, that studying its past could help us protect our future. If a greenhouse effect could destroy a world so similar to ours, could it happen here too? Are we standing on a path Venus once walked? Or did something else push it toward that fate, something we cannot see, something long gone? There's no clear answer, just quiet evidence and a heat that never leaves. When we sent probes to Venus, they did not last long. The Soviet Venera landers, the only ones to reach the surface, survived for minutes, not hours. The heat, the pressure, the acid, it overwhelmed everything. Their cameras clouded, their electronics failed, their signals faded in static. No rover has ever moved across Venus's ground. No human hand has touched it. And maybe that's for the best. Some places are meant to be wondered about, not reached. Some stories feel more powerful when they remain unfinished. Tonight, when you see Venus low in the sky, shining quietly over rooftops or hills, remember this. It once might have known water. It might have known peace. It might have known songs. And now it does not. But does it remember? And if it does, what would it say? The ground feels still. It holds our cities, our rivers, our forests. We build on it. We sleep on it. We trust it. But under everything we know, the Earth is moving, not just in circles around the sun, but beneath our very feet. Its crust, that thin outer skin, is not one solid piece. It is a puzzle of plates, drifting slowly on the mantle below. Each one glides, collides, or slips past another. Over time, continents have shattered and merged, mountains have risen and fallen, and the ocean floor has been pulled apart and remade. You cannot hear it, you cannot feel it, but the land beneath you is always shifting. Every hill, every valley, every coastline, none of them are permanent. They only appear still because we are too small to see the motion. But the Earth remembers. Its memory is written in layers of stone, in ancient seabeds found high on mountain peaks, in fossils buried in deserts that were once oceans, and deeper still there is more we do not understand. Below the crust, hidden from sight, there are vast pockets of water, not in lakes or rivers, but locked within the minerals of the mantle itself, enough to fill entire oceans. And yet we have never touched it. We only know it's there from tremors and shadows. The Earth holds secrets not just in space but in silence. Above the surface, our planet wears a magnetic field, a shield, invisible but strong. It protects us from the solar wind, from charged particles that would strip the air from our sky. But this field is not steady. It drifts, it wobbles, and sometimes, without warning, it flips. The north becomes south. The compass turns upside down. These reversals have happened again and again in Earth's history, not every 1,000 years, sometimes after 10 million, sometimes after 500,000. No pattern, no prediction, just change. We don't know what causes it, and we don't know what would happen if it occurred now. The field is weakening, not by much, but enough for some to wonder. Are we near another flip? Would our technology survive it? Would we? And yet, for all its motion, for all its change, Earth is balanced, delicately, beautifully, and by something even more surprising. The moon. That small, quiet companion in our sky does more than light the night. It steadies us. Its gravity pulls on Earth's oceans, drawing the tides in and out day after day. But it also keeps Earth's axis from tilting too far. Without the moon, our planet would wobble wildly. Seasons would swing out of control. Ice ages might come without warning, or never come again. The moon is slowly moving away, about 1.5 inches each year. Not fast, not soon, but eventually, Earth will lose that anchor, and when it does, the balance we depend on may begin to drift. We live in the eye of a moving machine. The outer crust seems calm, but below that, heat churns, fields reverse, plates grind, oceans are born in silence, and above it all, a moon watches us while drifting further and further away. We call this place home, but what does it mean? When home is always changing, the moon feels close. You can see it with your eyes. You can trace its shape with a finger against the sky. It rises, it sets, it pulls the tides. It has been our companion for as long as we've looked upward, but it does not glow, it does not breathe, and when struck, it does not break. It rings. In 1970, something strange happened. The Apollo 12 mission left behind seismic instruments, machines meant to listen, to record the tiny trembles beneath the lunar soil. After the astronauts left, NASA deliberately crashed a spent rocket booster into the moon's surface. It was an experiment, a chance to hear how the moon responds to a deep, direct impact. What came back was not what anyone expected. The signal shook the seismometers, not in one sharp jolt, not in a quick, dying rumble, but in a long, slow echo. The moon vibrated for nearly an hour, like a struck bell, clear, cold and eerily sustained. Nothing like Earth, where shockwaves scatter and fade within minutes. On the moon, the energy stayed. It pulsed. It lingered. The same thing happened again with later missions. More impacts, more echoes, and every time the moon rang, as if it were hollow, as if something inside refused to let the energy go. Scientists do not believe the moon is truly empty, but its structure is different. Its crust is dry, brittle. There is no water to soften the rock, no tectonic plates to shift and absorb shock. When something hits the moon, the force spreads outward and bounces around, slow, clean, undisturbed. The sound doesn't disappear. It holds. But still, the ringing stayed in people's minds, not just for what it meant, but for how it felt. It made the moon seem less like a rock, and more like a relic, something ancient, hollowed out, preserved. And there are other mysteries. The moon's origin is still debated. The leading theory says it was born from violence, that long ago, a planet-sized object slammed into Earth, and the debris formed the moon. But the details are messy. Some models say the moon should be made of different material, but it's not. It is almost the same as Earth's outer layers, too similar, too familiar, as if it came from us. Other theories say the moon formed elsewhere and was captured, but the math makes that unlikely. Something would have had to slow it down, something we can't find. There's no perfect answer. Even its orbit is strange. The moon is slowly drifting away, inch by inch. And yet, from our view, it appears the same size as the sun. That's why eclipses happen. A coincidence so exact it only exists for a brief moment in cosmic time. Long ago the moon looked bigger. In the far future it will look smaller. But now it fits. There are marks on its surface that don't match expectations, craters that are too shallow, ringed basins with no matching depth, impacts that should have shattered stone but did not. Some researchers say it's because of the crust. Others say we don't yet understand what's beneath. And then there are the moonquakes. They come in different types: deep, shallow, thermal. Some are caused by the sun warming the surface. Some come from tidal forces. But others, we don't fully understand. They shake from within, and they last longer than they should. The moon has no air, no wind, no rain. It does not change the way Earth does. The footprints left by astronauts will stay there for millions of years. Time does not move on the moon, not the way it moves here. It has no light of its own. It only reflects what it is given. And yet, it has shaped the story of life on Earth. Not by doing, but by being. By circling, by pulling, by holding. We look at the moon and see a companion, but perhaps it is more than that. Perhaps it is a witness, a memory of what came before, a bell waiting to be struck again. And if it rings, what might still be listening? Mars is dry now, covered in rusted stone and quiet dust, but it wasn't always like this. There are traces still of something softer, something flowing. In the deep cuts across its surface, wide channels that twist and fork like forgotten rivers, Mars remembers water. Some of these channels stretch for hundreds of miles. They curve and narrow the way streams do, when they shape a world slowly. But no stream runs through them now, just fine red sand carried by wind. The rivers are gone, and the lakes. And what might once have been oceans, but the shapes they left behind remain, carved into the skin of a planet that once held life's favourite element. Near the poles, the last water waits in frozen caps. Beneath the surface, more may lie hidden, not just ice but liquid. Kept warm by the pressure of the soil, maybe deep enough to still move, maybe deep enough to hold something ancient. We have not dug far. We have only brushed the top. But sometimes the air tells stories too. Tiny bursts of methane appear, then vanish. They rise in seasons. They change with time. On Earth, methane comes from life, from things that breathe, or from heat breaking ancient rock. On Mars, we don't know. It could be the whisper of buried microbes, or just chemistry still echoing from the past. Either way, it's a sign that something beneath the surface isn't sleeping. Mars used to be different. Long ago, it had an atmosphere. Not as thick as Earth's, but enough to hold clouds, enough to keep warmth near the ground, enough maybe for rain to fall, but that changed. Billions of years ago, Mars lost something vital, its magnetic field. Without it, the solar wind began to strip away the air, slowly, endlessly, until the sky thinned to almost nothing. Now, sunlight passes straight through. Heat escapes without being held. The surface swings from warmth to freezing in hours, and without pressure, water can't stay liquid. It either freezes or vanishes. What's left is a planet where the memory of water clings to stone. And still, we search. Rovers crawl across dusty plains. Orbiters scan for clues. We listen for patterns. We study salts in dry lake beds. We send machines to dig, to drill, to watch the sky. Because something about Mars feels like it almost made it. Like it came so near to being like us, and then, quietly, it did not. There is a sadness in that. A planet with the right size, the right ingredients, the right light, but just slightly wrong in timing, slightly wrong in fate, and yet we're drawn to it. We name its craters, we track its seasons, we picture ourselves walking there, not just because we can, but because it feels like reaching out to someone we lost, someone we want to understand. Mars doesn't speak, but it remembers, in the frozen caps, in the cracked soil, in the faint scent of methane drifting through thin air. And maybe, just maybe, beneath all that red dust, something still waits to be found. But if we find it, what will it say back? Jupiter does not whisper. It roars. When Voyager flew past it in '79, it carried with it more than cameras. It carried ears. instruments sensitive to radio waves. What it recorded wasn't quiet, it wasn't subtle, it was yelled. Jupiter sent out a sound like nothing heard before, deep, rising, pulsing tones, bursts, whines, howls, as if the planet itself was alive and shouting. Later, Juno listened too. It drifted close through Jupiter's magnetosphere and captured the same strange symphony. Not just static, not just hums, but patterns, storms made of electricity, signals launched from the spinning poles, giant arcs of sound moving through invisible fields. The kind of music no creature was meant to hear, and yet somehow it stays with you, long after the recording ends. Jupiter is massive, so massive that all the other planets combined still don't equal its weight. Its gravity is a force that shapes the solar system. It holds more than just moons. It holds history and motion and secrets. But for all its size, something strange happens inside. Jupiter gives off more heat than it receives from the sun. It glows slightly from within. A leftover fire, maybe, from its birth. Or perhaps something else. No one knows for sure. But the planet is not cold. It breathes energy without needing sunlight. Above its swirling clouds, lightning flashes brighter than any seen on Earth. Not just in storms, but everywhere. The atmosphere is restless. Its upper layers move in belts, some in opposite directions. Winds scream across the surface at hundreds of miles per hour. But beneath those clouds, no one knows what lies. There is no ground, no land, just deeper layers, more pressure, more gas, until eventually it becomes something else entirely. And there, among the storm bands, is the great red spot. It is not a place. It is a wound in the sky, a storm larger than Earth itself spinning endlessly for at least 350 years, maybe longer. It never stops. It never settles. We've watched it shrink and change colours, but it remains, a reminder that some things outlive even nations. Surrounding all of this is Jupiter's magnetic field, the largest structure in the solar system, aside from the sun's own influence. It traps radiation so intense it would kill a person in seconds. This invisible shield stretches millions of kilometres, and inside it everything moves. Moons, plasma, dust, the planet's own voice, and that voice is not silent. It rises and falls in frequencies too low for us to hear unaided, but when translated, it becomes haunting, mechanical, almost mournful, and yet it's natural. Jupiter speaks because its energy must move, and space is the only place big enough to hold that sound. We have never touched Jupiter. We never will. There is nowhere to stand, no place to land, but we have listened. And when we do, it feels like we're eavesdropping, like we are hearing something that wasn't meant for us. But if it isn't speaking to us, then who or what is it speaking to? Saturn moves slowly across the night sky, golden and soft, with its rings tilted like a crown no other world wears. From far away it looks solid, heavy, regal. But the truth is stranger. If you could place it on a vast enough ocean, Saturn would float. It is the only planet in the solar system light enough to do that. It is bigger than Earth by far. Its volume could hold more than 700 of our planets, but it's made mostly of gas, hydrogen and helium stretched into thick layers over a dense core we cannot see. There is no surface to touch, no ground to land on. It's not solid, it's deep and strange, like a cloud pretending to be a world. Its lightness is not weakness. It holds powerful storms deeper than we can imagine, and at the North Pole a storm shaped like a perfect hexagon spins in place. 6 sides, straight edges, a shape formed not by design but by wind. No one knows why it holds that shape, or how it stays so precise, but it has been there for decades, maybe longer. And then there are the rings. They look thin, fragile, but they stretch wide enough to fit several Earths side by side, made of ice and rock, some pieces as small as grains of sugar, others as large as mountains. From a distance the rings seem solid, But they are not. They are millions of pieces moving in harmony, orbiting in narrow lanes, dancing to the gravity of nearby moons. Cassini, the spacecraft that stayed with Saturn for over a decade, recorded faint sounds coming from the rings. Not voices, not music, but something. Tiny vibrations, rhythms caused by particles moving, moons pulling, waves echoing through ice. The data was turned into sound, and what it revealed was quiet, flickering, whisper-like, as if Saturn was humming under its breath. Everything about Saturn feels balanced. It spins fast, but its shape stays smooth. Its rings look chaotic, but they form patterns, spirals, gaps, waves. Its storms rage, but never tear the planet apart. In a solar system of sharp edges and broken moons, Saturn feels graceful. A place where even violence wears a gentle face, but it too is changing. The rings are fading, slowly. A little ice falling every year into the planet's gravity. A process called ring rain. It may take millions of years, but one day the rings might vanish, and Saturn will still turn, still shine, but without its most beautiful feature. So when we look up at it now, still whole, still glowing, we are seeing a moment that will not last. There is a world orbiting Saturn, hidden behind layers of golden haze. It glows softly in the infrared, but to the eye it appears still, a faint light wrapped in cloud. This is Titan, bigger than Mercury, heavier than our moon, and stranger than almost anything we've found. Its sky is thick, orange and dim, made mostly of nitrogen, like Earth's, but far denser. The air would crush your lungs and freeze your breath before you could speak. The surface lies in deep shadow where sunlight barely reaches, and yet, beneath that sky it rains. But it is not water. On Titan the clouds are made of methane. When they grow heavy they weep onto the frozen ground. It rains in drops, in storms, in sheets that fall across endless plains of ice and rock. These rivers carve valleys, they feed lakes, they form deltas that stretch for miles, and they vanish into basins filled with liquid so cold it does not boil. It waits. The lakes are vast, smooth, reflective. Cassini saw them from orbit, black mirrors glistening beneath the clouds. Some are hundreds of feet deep, others are shallow, branching into fingers, and some shorelines change over time, rising or retreating with the seasons. There are tides here, not from Titan's own pull, but from Saturn's. Every movement a reminder that this world is part of something larger. The temperature at the surface is more than 290 degrees below zero. Too cold for life as we know it, but not too cold for chemistry. Titan has a cycle, like Earth. Evaporation, clouds, rain, runoff. Just not with water. With methane. With ethane. With molecules that behave like ghosts of familiar things, echoing a world we recognize but through a different lens. There is geology too. Mountains, dunes, ice volcanoes that may erupt not fire, but ammonia. Something within Titan shifts, moves, builds. This is not a dead moon. It is dreaming beneath the surface, breathing slowly in ways we still cannot measure. And maybe living. Some scientists believe there could be life here. Not in water, but in methane. Life with a different structure, different rules, a biology that does not need warmth, only time. If such life exists, it would not look like anything we know. It would not feel familiar, but it might still grow, adapt, respond. It might still sense its world in ways we cannot imagine. Titan is the only place besides Earth where we've seen lakes on the surface, where weather falls from the sky, where land meets liquid. But everything about it is reversed, reflected. A mirror made of gas and silence. One day we may go there. We may land, float, drift across its lakes in boats made for another kind of ocean. But until then we listen, we watch, we wonder, and the methane continues to fall, drop by drop. A slow, quiet rhythm on a world that remembers rain. Uranus does not turn the way other planets do. It rolls, slowly, quietly, like something that was pushed long ago and never recovered. Its axis tilts more than 98 degrees, so far that it moves through space on its side, with its poles where its equator should be. No other planet in the solar system spins like this. No other planet looks quite so wounded. Most believe it was struck. Billions of years ago, during the chaos of formation, a massive object may have collided with Uranus, knocking it off balance. Not enough to destroy it, but enough to twist its entire life. The planet kept spinning, the moon stayed, the rings reformed, but everything tilted, and everything stayed tilted. Its rings are thin and dark, hard to see even through telescopes, but they're there, circling not above or below, but around the sides. The moons follow that same strange path, orbiting vertically, like a clock turned on its edge. It feels unnatural, and yet it's real. The entire system leans, as if gravity forgot which way is down. Because of this tilt, Uranus has seasons unlike anything on Earth. Each pole spends more than 40 years facing the sun directly, then 40 years turned away. For half a century, one side sees daylight without end, while the other falls into an extended night. And then they trade places, slowly, unevenly, quietly. Its colour is soft, a pale blue-green haze that hides what's underneath. The outer atmosphere is calm, too calm. While Neptune storms with winds and energy, Uranus remains still. We don't know why. It should give off heat from within, like other giant planets. But it doesn't. It's quiet on the inside too. No glow, no pulse, just a faint silence where we expected fire. And yet it is massive, icy, dense. It holds secrets in layers we have never touched. No spacecraft has orbited Uranus. We've only flown past it once, decades ago, a brief encounter, a glimpse through clouds and then distance again. Even its magnetic field doesn't line up. It tilts too, not with the planet, not with its core, offset, skewed, warped. The field swings as Uranus rotates, creating odd waves and shifting radiation. It behaves like it doesn't quite belong to the planet that carries it, like it's been knocked loose. The moons of Uranus have names pulled from poetry and plays: Miranda, Ariel, Umbriel, Titania, Oberon. Some are smooth, others are broken. Miranda in particular looks torn apart and stitched back together, as if gravity tried to destroy it and then changed its mind. Deep canyons slice through its surface. Ridges rise without reason. It is beautiful, but unsettling. Uranus feels distant, not just in space, but in feeling. It does not roar, it does not burn, it drifts, tilted. The farthest major planet spins fast, faster than you might expect for a world so distant, so dim. Neptune, dark blue and cold, turns every 16 hours, stirring its skies with winds that break the rules. Here, in the deep edge of the solar system, storms travel faster than sound. Not through air like on Earth, but through the sheer weight of hydrogen and helium wrapped in ice-blue clouds. The great dark spot once swirled across its atmosphere, a deep hole in a field of gas. It was vast, wider than Earth. Then one day it vanished, just gone, no trace. Later another appeared. Then that too faded. On Neptune, storms do not age slowly. They rise with fury, then disappear like ghosts. Even our best telescopes struggle to follow them. Even our machines feel distant here. Winds here can reach over 200 miles per hour. On Earth, that would shred cities. On Neptune, it's the normal rhythm. The clouds twist like ribbons, striped with bands that glide in opposite directions, pulled by the unseen forces. Beneath those clouds, deeper than light can reach, lies mystery. A spinning core that still gives off heat. More heat than it receives from the sun. Neptune glows faintly in infrared, like a memory that cannot be fully erased. And then there's the tilt. Its magnetic field is not aligned with the planet's centre. It's tilted, twisted and offset. Like the whole world is trying to speak, but its voice comes from somewhere else. It spins not in harmony but in conflict, its interior out of sync with its shell. No one knows why. Compared to its neighbour Uranus, Neptune should be quiet. Uranus is closer to the sun, yet colder. It barely moves. But Neptune, farther, darker, pulses with energy. It is not supposed to be this active. It is not supposed to be this alive. And still it spins with storms we cannot explain. Perhaps the answer lies deep within. Perhaps something strange churns at its core, something we cannot yet touch. Voyager 2 was the only spacecraft to visit. It passed by in 1989, a short visit, a distant flyby, but in that brief moment it caught clouds moving faster than its own camera, lightning flickering in darkness, a planet that seemed to carry its weather like a secret. Since then, we have only watched from afar, and Neptune does not share much. There are moons here. Triton, the largest, moves backward, against Neptune's spin, a captured object perhaps. It spews geysers from its icy surface, dark streaks marking its frozen plains. But even Triton cannot explain Neptune. It only adds to the feeling that something here does not quite belong. Neptune's atmosphere holds methane, giving it that deep, cold colour. But colour is not enough to reveal its story. We do not know how the storms form. We do not know why they vanish. The planet remains, and it turns, always turning. Its rings are thin, faint, like whispers drawn in dust. They are uneven, clumpy, like broken pieces circling quietly. They were not discovered until we looked closely. Everything on Neptune hides behind layers of gas, of distance, of silence. In a system where the sun is only a distant star, Neptune dances in a space that feels almost separate, not lost, but drifting, still part of our family, but far enough to forget what warmth once felt like. And yet it is not quiet. It moves, it fights, it changes, it sings in its storms, and somewhere beneath those shifting clouds, in places we have never touched, Neptune keeps secrets locked in pressure and wind, secrets that still resist the light. It was once the 9th planet. Then it was cast out, too small, too strange. But Pluto never stopped moving. It never stopped breathing. Across its frozen surface lies something unexpected, a pale, heart-shaped plain. One side is smooth and bright, filled with nitrogen ice. We call it Sputnik Planitia, but it is not just a shape. It moves, it shifts, it pulses, slowly, gently, like a breath beneath frost. When the New Horizons spacecraft flew past in 2015, it saw a world no one expected, not lifeless, not frozen in time, but changing, growing. Nothing was stirring under the crust. It saw cracks, plains that looked young, ice that should have melted long ago. Somehow Pluto was still alive. The heart is not just pretty, it tugs at the entire planet. Its weight pulls Pluto slightly to one side, changing its balance. It may even cause Pluto to wobble as it spins. And beneath that heart, we believe there is something more, a possible ocean, buried deep under rock-hard ice. Not water as we know it, not warm, but liquid, moving, existing. Somewhere in that darkness, a sea might wait. Silent, untouched, ancient. If it's real, it means Pluto kept some of its warmth. It means that something soft survived in a place made of silence and shadow. Around Pluto orbits Saturn, a moon half its size. They spin together, always showing the same face locked in a quiet dance. Saturn has canyons deeper than any on Earth. It has a reddish cap at its north pole. We do not know why. Some say chemicals from Pluto drift across space and fall onto Charon's ice, like dust from a breathless whisper. Together they drift on the edge of everything. Pluto's orbit is strange. Sometimes it comes closer to the Sun than Neptune. Then it slips away again. It takes 248 years to complete a single loop around the Sun. Most of the time it lingers in darkness. But that heart, it keeps pulsing. Cryovolcanoes may rise from its crust, not of fire but of ice, ammonia, water, subtle eruptions that leave smooth surfaces instead of ash. This is not a place of violence, it is a place of memory. Every crack tells a story. Every ridge is a whisper from something deep below. And yet it is small, so small that gravity cannot pull it into a perfect sphere. Mountains made of ice rise without sinking, shadows stretch longer. Light takes hours to reach it. But New Horizons showed us it is not empty. It is not dead, it is distant. But distance is not the same as absence. Pluto's skies may glow blue during its thin, hazy sunsets. A blue so soft, so fragile, it feels like a secret. It is not the colour of warmth, but the colour of longing. We saw it only once, for a moment, as New Horizons turned back for a final picture, and then it continued on. We left Pluto behind, but it stayed, spinning, breathing, pulsing beneath its icy skin. It has no rings, no great storms, no fire, but in its sense it holds something almost human, the need to be seen. They said it was just a rock, but even rocks can remember warmth. And somewhere far beyond the planets we call home, a heart-shaped light still lingers in the dark. Out where the sunlight fades, something strange begins. Beyond the orbit of Pluto, the solar system does not just end, it blurs. The wind that blows from the sun, made of charged particles and light, stretches far past the last planets. It thins, slows, and finally it meets something else, something older, something colder, the interstellar medium, space between stars. When Voyager 1 reached that invisible border, it found a place unlike anything before, a frontier not of rock or gas, but of pressure. The solar wind rushing outward for billions of miles crashed into the wind of the galaxy. It formed a boundary, a shock, a wall. We call it the heliopause, the end of the sun's breath. But Voyager found something more. It detected a kind of glow, a strange radiation, ultraviolet light that should not have been there. Scientists call it the hydrogen wall. It surrounds the heliosphere, a giant bubble inflated by the sun. Beyond it, space is not empty. It pushes back, just a little, just enough to burn. We think this wall is made of hydrogen atoms piling up from interstellar space, heated by the pressure where two winds meet. But we do not truly know. We cannot see it. We only feel it. The faint touch of particles against Voyager's ancient sensors, like fingertips brushing glass in the dark. No spacecraft has gone farther. Voyager 1 is now over 14 billion miles from Earth, and yet we still hear from it, not clearly, not loudly, but enough. A signal weak as a sigh arrives after travelling for more than 21 hours at the speed of light. Slower each year, fainter each season, but it comes. We do not know what lies beyond the wall, just that the temperature rises slightly. That space, which should be colder, somehow becomes warmer there. That energy, from somewhere, pushes in from outside. The sun is still powerful here, but it is no longer alone. Some believe we are inside a protective shell, a boundary that keeps most of the galaxy's radiation at bay. Others wonder what happens when stars pass close to our solar system and press against this invisible wall. Could they reshape it? Could they break through? Even the shape of the heliosphere is debated. Some say it is round, others say it stretches behind the sun like a comet's tail, like a tear in slow motion trailing behind us as we move through the galaxy. And then there is the silence. Beyond the wall, cosmic rays become louder. The interstellar wind becomes stronger. But there are no planets, no moons, only ice, dust, and the long quiet between stars. Voyager crossed into that place. It left everything behind, even the sun's warmth. But not us. We still listen. We still wait. Somewhere past that wall, the rules begin to change. Gravity grows weak. Light takes longer. Heat barely moves. And yet, Voyager goes on. powered by a fading battery and the last bits of warmth from a nuclear heart. It carries messages from Earth, a golden record filled with music, greetings, and the sound of a human heartbeat. It was never meant to return, it was meant to be found. Maybe one day something will find it, or maybe it will drift forever, a silent letter with no one to read it. But right now it is near the edge, the true edge, where fire turns to frost, where pressure becomes emptiness, where everything known begins to vanish. And the strange part? Just before that vanishing point, it glows. It is easy to forget that the sun is not silent. From Earth it seems calm, warm, predictable. It rises, it sets, it glows. But beneath that golden light is a force so deep, so constant it hums, not with sound we can hear, but with pressure, with motion, with waves that travel through the heart of a star. Inside the sun, gases shift. Pressure builds and collapses. These movements send out ripples, like vibrations in a bell. But the sun is not a bell. It is a sphere of fire and plasma, layered with zones that churn and pull in different directions. As these waves bounce around, they create patterns, harmonies. The sun rings. We cannot hear it with our ears, but we have learned how to listen. In ultraviolet light, in magnetic fields, in tiny shifts in brightness, the sun speaks. And when scientists translated those vibrations into sound, something haunting emerged. A deep layered tone, almost like a breath stretched over hours, a slow living heartbeat beneath a burning skin. These are not random noises, they are part of the sun's rhythm, a cycle that repeats again and again over 11 years. At its peak, the sun boils with energy. Solar flares erupt like explosions. Magnetic storms twist and snap. At its quietest, the surface smooths, the voice lowers, the music softens, but it never stops. Even now, satellites like SOHO and SDO orbit high above Earth, watching every flicker, listening to every wave, not just to understand the sun, but to prepare, because its song is not always gentle. Sometimes it screams. Solar flares, bursts of energy from tangled magnetic fields, can launch walls of radiation toward us. Massive clouds of charged particles, called coronal mass ejections, fly across space. If they hit Earth, they shake our satellites. They overload our power grids. They paint the skies with auroras, and sometimes they break the machines we rely on. The sun does not aim. It breathes. It pulses. It lives. And we live under its moods. But it is also beautiful. The light from its surface takes just over 8 minutes to reach us, but the light from its core takes thousands of years to rise and escape. Every sunrise we see is ancient. Every photon that warms your face began long before you were born. And all the while the sun sings. It sings through ultraviolet rhythms that shape the upper atmosphere. It sings through radio waves and X-rays and sudden, unpredictable flashes, and deep inside where no light can reach, its vibrations echo across a sea of fire. The music of a star is not just poetry, it is a map, a way to see inside something we can never touch, like feeling the heartbeat of a giant from the outside. When we listen to the sun song, we are not hearing chaos, we are hearing structure, balance, motion that never stops. It is a reminder that even the brightest, hottest, most dangerous things can still carry order, can still carry rhythm. And sometimes, late at night, a spacecraft hears the hum, translates it, sends it home, and we listen. Because beneath everything we know, every planet, every moon, every field and ocean, lies that song, always beneath us, always above us. It is the pulse of the solar system, and it never truly goes quiet. They do not pass like hours. They do not break and vanish in a few days. These storms, they linger. They live. Some have lasted longer than the nations we belong to. Some are larger than the Earth itself, turning, raging and rising in skies no human has ever breathed. On Jupiter there is one. You can see it from across the solar system, a swirling reddish oval called the Great Red Spot. It has been there for at least 350 years, maybe longer. We do not know exactly when it began. It was already turning when we invented telescopes good enough to see it. Since then, it has grown, shrunk, shifted, and survived. Still spinning, still there. The Great Red Spot is a storm twice the width of Earth. Its winds circle at over 400 miles per hour. And yet it holds its shape. It endures. Around it, other storms come and go. Bands of gas drift like rivers. Lightning cracks deeper than we can see. But the red spot remains, like an eye that never closes. It is not the only one. On Saturn, near the North Pole, something strange awaits. A storm shaped like a hexagon. 6 perfect sides. A geometric pattern in clouds. And it is massive, each side longer than the width of Earth. Winds rush along its edges in a clean, endless loop. Inside, a vortex swirls down into darkness. We have no storms like this on Earth. We do not understand how something so large can stay so perfectly shaped. Some think it is caused by jet streams, others believe it is a resonance deep inside Saturn's atmosphere. But no answer is certain. The storm just turns, always in silence. Further still, Neptune hides its own secrets. It is cold there, dark, far from the warmth of the sun, yet Neptune is alive with movement. In 1989, Voyager 2 flew by and saw a huge dark storm near the equator called the Great Dark Spot. It was nearly the size of Earth. But when we looked again, years later, it was gone. Another appeared near the pole, then that one vanished too. Neptune's storms form quickly. They shift, fade, and reappear like ghosts. Their winds, the fastest in the solar system, reach over 100-200 miles per hour. That is faster than the speed of sound on Earth. Nothing we know moves like that in any sky we have walked beneath. And yet these are not storms in the way we usually think of them. There are no raindrops, no thunder we could hear. These are waves of gas and pressure, cyclones of ammonia, methane, hydrogen, spinning endlessly in atmospheres hundreds of miles deep. On Earth, storms begin when warm air rises and cool air falls. The oceans feed them, mountains block them. They twist and break across our land. But on the gas giants there is no surface, no ocean shore, no forest line, just sky after sky after sky, and the storms float freely inside them, held by nothing. Sometimes scientists wonder if storms could exist even deeper, in layers we cannot see, beneath the clouds, beneath the haze, where pressure turns gas into liquid. Could there be weather there too? Storms inside planets, invisible but real? Even on planets where we expect calm, storms find a way. Venus is covered in clouds, thick, toxic, and hot enough to melt lead. But high above that crushing surface, winds whip across the planet at nearly 200 miles per hour. The entire atmosphere rotates faster than the planet itself. No one knows why. It is as if the sky has decided to race, while the ground turns slowly beneath it. And then there are the places where storms may never end. Places where they are not events, but states of being. Jupiter's bands, Saturn's belts, the polar vortices that spin forever, without pause. These are not weather patterns, they are features. They are built into the planets themselves. There is something strange, even emotional, about this. To think that storms, these vast, violent things, can last longer than civilizations. That they can rise and breathe and change for centuries. When we stand in a storm on Earth, we wait for it to pass. We shelter. We endure. And when the clouds clear, the world feels different. But imagine if it never cleared. If the winds never slowed, if the sky never calmed, what kind of world would that be? What would it feel like to grow up under a storm that never left? The planets out there have no homes, no cities, no voices, but they have storms, they have motion, they have scars in the air that tell us something is always happening, something ancient, something powerful. Maybe one day a ship will fly into the red spot. Maybe it will descend into that endless swirl and finally touch what no one ever has. Maybe it will vanish before we understand, but until then we watch. We watch the skies of other worlds and realize how small our weather is, and how big a storm can truly be. Far beyond our world, where the sunlight is thin and time feels heavy, something impossible is happening, not in fairy tales, not in dreams, but in the atmosphere of two distant giants, Uranus and Neptune. It begins deep inside them, deeper than light can reach. Pressure grows until atoms move differently, closer, tighter. The heat is still low, the cold is crushing, but the pressure, it builds, and carbon, simple common carbon, begins to shift. It does not burn, it does not melt, it changes and it becomes crystal. On Earth, we shape diamonds in fire, we cut them for beauty. We lock them in rings and necklaces, wrapped in love or vanity. But out there, diamonds fall like rain, not gentle, not sparkling. They fall as jagged shards. They form in darkness, where no one watches, and they drop through layers of gas, heavier than stone until they vanish below, maybe all the way to the core. Some scientists think these diamonds gather in great layers, like coal, but made of jewels. Others believe they melt again before they land, crushed by weight we cannot imagine. No one has seen them. No probe has flown that far, that deep, but the math says it is real. The physics says it can happen. It likely already is. We once made this rain in a lab. In a flash of light and force, carbon became diamond under conditions that mimic Neptune's belly. Just for a moment. Just to say it could be done. But that was a whisper. The real rain, the endless silent fall, belongs to those planets. And it might not stop there. Out in the galaxy, beyond our tiny solar system, there may be entire planets made mostly of carbon. Some of them could be full of graphite, others diamonds, not a storm, not a layer, a world where the mountains shine and the ground cuts like glass. We have never seen one, but the universe is old. Stars are born and die, elements mix and collide. There is no rule that says Earth's recipes are the only ones. Somewhere in the dark, a diamond planet might be spinning slowly. No eyes to see it, no hands to hold it. And that is the strangest part. Here, diamonds mean wealth. They mean power. They're stored in safes sealed behind alarms. But out there, they're as common as dust, piled beneath clouds, buried in silence. It changes the way we think about value, about beauty. It reminds us that the universe does not care what we treasure. It does not sparkle for us. It creates endlessly without reason or audience. And if a storm of diamonds falls alone in the dark, is it still beautiful? Maybe it is even more so, because it proves that wonder does not wait for us. It exists with or without our eyes. It reigns where no one hears. It shines in places no one may ever visit. And somewhere right now in the slow churning depths of a distant gas giant, it is raining again. Not water, not ice, but diamonds, falling forever, vanishing into the deep. Beneath a shell of frozen silence, a secret moves. Europa, one of Jupiter's moons, looks quiet. Its surface is a sheet of ice, cracked and scarred like broken glass. No colour, no trees, no sky, just pale white stretching into black space. But under that stillness, something ancient stirs. We used to think it was just another icy moon. Cold, empty, dead. But the more we looked, the more it whispered. The cracks were too many. The surface too young. Some parts looked melted like they had shifted from below. And then, through thin plumes of vapour, we saw something rise. Water. Real water. From deep inside. It was not just a small reservoir, not a hidden lake. It was an ocean. Vast. Deeper than Earth's, and sealed in complete darkness. Imagine that for a moment. An entire ocean, stretching for thousands of miles, hidden under ice so thick, sunlight has never touched it. No tides from our moon, no winds, no sky, just pressure, warmth from below, and motion. How does it stay liquid? Jupiter is the key. Its gravity pulls Europa over and over, squeezing it like a slow breath. That flexing warms the moon's insides, not enough to melt the surface, but enough to keep the ocean flowing underneath. We see the evidence in strange shapes on the ice, long fractures, swirls of chaos terrain, places where the surface rose and shifted, as if something below had pushed gently upward, not to break through, just to remind us it is there. And sometimes it does more than whisper. In certain places, jets of water erupt straight into space, geysers, miles high. Not steam, but icy mist from that dark sea, escaping through cracks. Our spacecraft have flown through it, tasted it, measured it, and what they found was simple and extraordinary. Salts, organics, the building blocks of life. Nothing alive has been seen, no glowing creatures, no alien fish, but the ingredients are there, the pressure, the heat, the water, all hidden from light yet active. On Earth, we find life at the bottom of oceans, near vents where sunlight never reaches, entire ecosystems, thriving in the dark, feeding on minerals and warmth. No plants, no photosynthesis, just life, born from heat and chemistry. Europa may have that too, and not on the surface, never in the cold, but miles below. Something could be moving, breathing, living, waiting. No human has touched that sea, no robot has swum in it, but someday one might. A lander may drill through the ice, a probe may dive into the black, and if it finds something, even a single cell, everything will change. We would no longer be alone, not because we met a civilization, not because we heard a message, but because we would have proof that life can begin twice, once here, once there, that life is not rare. It is written into the universe, and Europa is not the only one. Other moons, Enceladus, Ganymede, Titan, may have oceans too, each locked in ice, each warmed from within, each holding secrets we cannot yet reach. But Europa came first, the one we noticed, the one that moved beneath the silence. And if we ever speak of first contact, it may not be with a voice, it may not be with light, it may be the sound of water, touched for the first time in billions of years. And maybe in that stillness something stirs back. Some stars are born alone, but most come in pairs. In the places where stars are made, clouds of dust collapse under their own weight. But that collapse is rarely perfect. Sometimes the spinning mass tears in two. One becomes a star and the other becomes its twin. Our sun burns steady and alone now. Bright, warm, familiar. It holds our planets in orbit, feeds our skies with light, and carries our stories in its glow. But many scientists believe it may not have always been alone. They call it the nemesis hypothesis, a quiet theory whispered at the edge of science and mystery. It suggests that long ago our sun had a companion, another star, dimmer, colder, farther away, a twin that circled through the deep. It would not have been like the sun. If it existed, it was likely a brown dwarf, a failed star. Not bright enough to shine, not strong enough to last, but heavy and dark, wandering the outer reaches of our solar system unseen. Why believe in something we have never found? Because something keeps touching the past. Earth's history carries patterns, long cycles of mass extinctions. Life blooms, then vanishes, then returns again. Some believe it could be cosmic, a distant orbit swinging through the Oort cloud every few million years, disturbing comets, sending them inward. Not with intention, not as an enemy, but as a ghost. A twin that does not speak, but moves through time with gravity alone. We have searched for it. Infrared surveys, sky scans, nothing confirmed, no reflection, no heat signature we can trace. But the space beyond Neptune is wide and very dark. Maybe it was there once. Maybe it left. Maybe it broke apart before it ever fully formed. Or maybe still waits, drifting gently beyond the edge of light. What does it mean to lose a star? If the sun had a sibling, they were born from the same dust. They came into being side by side and then, drifted apart forever. One became our anchor, the other something forgotten, and even if it was never bright enough to shine, it might still carry a shadow of that bond. We would never feel it, it would never warm our sky, but its presence, its SIGINT pull, might still leave a trace on the things we cannot explain. Perhaps we will find it one day, a pale orb, ancient and cold, circling in the dark like an echo from before time began. Or perhaps we never will, and it will remain a story, a theory that fills a gap in what we know without proof to hold. But the idea lingers, that we are not only orbiting a star but mourning a companion, that the universe, so full of pairs, began our story with two flames and left us with one, and that somewhere, far beyond the last planet, a second sun may still turn, not to light the sky, but to remind us what once was. It moves the wrong way, not by mistake, not by accident. Triton orbits Neptune backward against the planet's spin, like a thought out of place in an otherwise structured mind. Most moons circle their planets the way the planets spin, as if born together, moulded from the same early dust and gravity. But Triton is a stranger. Scientists think it was captured, that once it was drifted through the Kuiper belt, cold, alone and free, before Neptune's gravity caught it. Not gently, not easily. It would have been a violent meeting, the kind that erases past lives. Triton may have once had companions. It may have been its own world, maybe even with its own moons. But that freedom ended in an instant, pulled into a new home, chained into orbit, but never allowed to truly belong. Because Triton did not settle quietly. Its arrival may have torn through Neptune's own system. Any earlier moons would have been scattered, flung away or swallowed whole. What we see now, this lonely moon spinning the wrong way, is not just strange. It is the memory of a collision that never finished screaming. And still, Triton is alive. Beneath its frozen crust there are signs of motion. Plumes burst upward, geysers of ice that fall back like snow. The surface is smooth in places, young, as if something inside still moves, still breathes through cracks. This is not a dead rock. It may be quiet, but it is not still. Its atmosphere is thin and ghostly, just enough to hug the ice, just enough to suggest that something is still escaping from inside. But it is faint. You would not feel it on your skin, only instruments can hear it whisper. We have seen what might be cryovolcanoes, not lava, but water or ammonia erupting into the cold. Volcanoes that freeze, not burn, volcanoes that speak in sighs, not fire. What kind of world lives like this? Frozen on the outside, tugged from within, never quite at home. Triton's backward path is not just strange, it is a countdown. Every orbit steals a little more energy. Every year it spirals closer to Neptune. Not fast, not in our lifetimes. But one day it will cross a point of no return, and then it will fall. The gravity will pull it apart piece by piece, the ice will fracture, the core will twist and tear, and what remains may become a ring, a thin, silent halo around the planet that once claimed it. Beautiful, but only from a distance. Up close it will be the story of a moon that was never supposed to be there. We do not know when, it could take billions of years, but it will happen. Triton is a borrowed moon, its orbit is a promise written in decay. Gravity does not forget. And yet, it lingers, not just in space, but in feeling. There is something deeply strange about watching a world that moves against everything around it. Something unsettling, like seeing a clock run backwards, like a dream where up feels like down. Triton makes us question what we think is normal, what we think is stable. It reminds us that not all moons are born beside their planets. Some are taken, some are changed. Some carry old stories into new skies, and no one asks them if they want to stay. It is easy to think of moons as sidekicks, as parts of a system, but Triton forces us to see something else, that even in the silence of space there can be tension, that orbits can fight, that belonging is not always a given, and maybe that's why it stays with us, because it reflects something in us too, the part that drifts, that resists, that remembers a life before we were captured by whatever holds us now. There is no other moon quite like it, and one day there may be nothing left of it at all, but tonight it circles Neptune. Backward, always backward. Somewhere far beyond Neptune, something cold moves through the dark. It is small compared to planets, distant, almost invisible, but it pulls on what we thought we knew. Its name is Eris, and when we found it, everything changed. We once believed there were 9 planets, 9 names, 9 places that made up the map of our solar system, and then Eris appeared, slightly smaller than Pluto, heavier, icy, mysterious. It moved through the outer void, not like a planet, not like a comet, but like something else, something that challenged the shape of our story. Because if Pluto was a planet, so was Eris, and if Eris was just a rock, then maybe Pluto was too, so we chose, and in choosing we let go. Pluto lost its title, the number became 8, and Eris became the ghost of what might have been, a planet that never quite was. But it was not alone. Eris was only the first of many. Make, Haumea, Sedna, Quaoar, worlds with strange names and stranger paths. Their orbits stretch so far they barely graze the light. Some take hundreds of years to circle the sun once. Some never come close to the other planets. They move like thoughts on the edge of sleep, faint, drifting, just barely real. We call them dwarf planets, but the term feels like a whisper, as if we are still unsure what they really are. Not full planets, not comets, not moons, just other. They do not fit cleanly into the boxes we built. They ask questions instead of giving answers. Where did they come from? Were they born here, or did something long ago throw them off course? Why do they stay so far from the centre? Why do they never draw near? Sedna especially is strange. It has no clear reason to be where it is. Its orbit is long and stretched, like it was pulled by something big, something we have not seen. Some think it came from a different star system. That long ago, the sun passed close to another star and borrowed pieces from its disk. Sedna could be one of those pieces, an adopted child still wandering the edge. If that is true, then not everything here belongs here. Some of it may have drifted in or drifted out. The borders of the solar system are not as clean as we thought, and in that space, that messy edge, is Eris, the planet that made us ask what a planet even is. It has a moon, it has seasons, it reflects light like fresh snow, but it is not counted with the others. It is on the list, but never in the conversation. It did not lose anything, it never held it. But sometimes that is harder, because Eris reminds us that the cosmos does not care about categories, it simply moves. And what we call something does not change what it is. Eris has been circling the sun for billions of years, long before we saw it, long before we argued over its name. It will continue long after us. It is hard not to feel a kind of sorrow in that. Not because Eris minds, but because we do. We look to the stars not just for facts, but for meaning. We want stories, we want patterns. And Eris broke one. It said, "Your map is too small," and it was right. Out there beyond Neptune, the space is not empty. It is thick with debris, with remnants, with things we have not yet seen. Not just Eris, but a whole population of forgotten things. They are not visitors, they are not intruders. They have been there all along, we just did not know how to see them. So we gave them names, we drew new lines, and we moved forward. But something stayed behind. Some quiet echo of what it felt like to lose a planet, or to find one and be told it never counted. The solar system is not made of just 8 places. It is made of thousands, some large, some broken, some glowing faintly in the dark. Eris is not the exception, it is a door, and behind it is a world we have barely begun to understand. It is not ours, it never was, but we orbit the same sun, and that somehow still connects us. There is a place beyond Neptune where the light fades but never fully vanishes, a distant ring too wide to see with the eyes, too scattered to feel like a wall. It is called the Kuiper Belt, and it is not empty. For a long time we thought the solar system ended at Pluto, a single line, a cold edge. Beyond that, only stars. But the truth is more complicated. What lies past Pluto is a sprawling field of icy bodies, leftovers perhaps from the earliest days. Billions of fragments, each one circling the sun on its own quiet path. Some are tiny, some are as large as mountains, a few like Haumea and Makemake are worlds of their own, all of them cold, all of them old. Some have not changed in billions of years. They are not arranged neatly. There are gaps, clusters, spirals of motion. Some move fast. Some drift so slowly it takes centuries to complete a single orbit. And the belt itself is wide, stretching from 30 astronomical units to perhaps 55. That is farther than the sun's warmth can touch. A place where time seems to slow, where light arrives late and leaves quickly. We used to think it was empty space, but now we know it is crowded with silence. The Kuiper Belt holds Pluto, Eris, Sedna, Quaoar, and thousands more with names we have not yet given. Some are locked in place by Neptune's gravity. Others seem to dance just outside its pull like they are avoiding its reach. What shaped this belt is still unclear. Some scientists believe Neptune moved outward over time, migrating slowly, pushing debris ahead of it, scattering smaller bodies behind. Others suggest that something massive once passed through, stirring the region like a spoon through dust. A rogue planet, a nearby star, maybe something else. There is evidence of violence. Many of these objects show signs of collision. Cracks, fractures, jagged shapes that suggest they were once whole. In some parts of the belt, the density is high, in others strangely low. Something disrupted it, but we do not know what. The New Horizons spacecraft, which flew past Pluto, kept going. It entered the Kuiper Belt. It saw another object, a contact binary called Arakoth, 2 lobes fused together, a shape that looks like a peanut or a snowman. Its surface is untouched by the wind or rain. It has likely looked the same since the solar system formed. That is what the Kuiper Belt offers, not just distance, but time. It is a museum of frozen things, a record of how the solar system began. The further you go, the further back you see, not in light like with stars, but in presence, in matter unchanged by age. Some researchers think the Kuiper Belt holds clues to how planets form. Others think it hides the reason why our own solar system looks the way it does. Some even wonder if life could have started in such a place, not on a warm world, but in the cold where chemistry moved slowly but persistently. What is most unsettling is how much of it remains hidden. We have only seen a fraction. Even with the best telescopes, most Kuiper Belt objects are too faint to find. They are small, dark and far away, like whispers behind a wall. Sometimes they appear suddenly, a new speck in the sky, a shifting orbit, a light curve that does not match expectations, each one a surprise, each one a reminder that the map is still unfinished. The Kuiper Belt does not behave like a simple ring. It is warped, tilted, messy. Some regions seem empty when they should not be. Others are crowded for no reason we can explain. It is not just a belt, it is a question. Why is it like this, or why did it survive? And what else is hiding in its frozen dark? Even now, New Horizons continues its journey. Beyond Arakoth, into deeper stillness. It sends back data in faint pulses. Sometimes it captures dust, sometimes it measures plasma. Each bite a piece of the puzzle. But the Kuiper Belt does not give up its secrets easily. It is vast, older than memory, and quiet in a way that feels deliberate. We used to look at Pluto and think that was the end. Now we know it was only the beginning. A doorway into something stranger, something broader. Out there, beyond the planets, is a second solar system, not made of bright worlds and moons, but of shadows, ice, and echoes. We have just stepped into it, and it does not seem to end. There are things we cannot see, but we can feel them. Far beyond Neptune, In the quiet freeze of the Kuiper belt, something strange is happening. The icy worlds out there are not drifting where they should. Their orbits are tilted, clustered, pulled off course as if by a hand we cannot find. Some scientists noticed it years ago. Odd patterns, distant objects too far to influence each other, all bending in the same direction. Not randomly scattered, but grouped. It was not gravity from Neptune. It was not a glitch in the data. It looked like something big was tugging at them. And yet nothing was there. They called it Planet 9, a ghost of math and motion. Not a new discovery, but a new idea, built from absence, from the orbits that no longer made sense. If it exists, it would be huge. Maybe 5 to 10 times the mass of Earth. Too far to reflect enough sunlight, too slow to leave a clear trail, but massive enough to tilt the edge of our solar system without ever showing its face. Some think it is a frozen super-Earth. Others say it could be a gas dwarf, wrapped in blue haze. A few believe it might be even stranger, a black hole the size of a grapefruit bending light as it passes through the dark. We have not seen it, but we have seen its fingerprints. Simulations suggest it could explain why certain objects cluster together at sharp angles, why some are tilted almost vertically compared to the rest of the solar system, why others are pushed so far out their orbits take thousands of years to complete. And the pull is not gentle, it is decisive. Objects that should orbit calmly now swing in wide arcs, drawn towards something hidden. Their paths stretch like tensioned ropes, as if held by something just out of reach. So why have we not found it? Because the sky is too vast, and the darkness too deep. A planet that far out would move slowly, like a shadow gliding across centuries. It could be in any direction, behind a star, beyond the reach of our telescopes, or simply in a place we have not looked. There is no clear path, no trail of crumbs, only hints, gravitational clues left behind by objects with names like Sedna and 2012 VP Bonvain, ghostly bodies that sweep through space on orbits shaped like tears. The idea of a hidden planet is not new. Once, Neptune itself was discovered through math, its presence predicted before anyone saw it. And Pluto, too, was part of that old chase, a puzzle piece that turned out to be the wrong shape. But this feels different. The data is mounting, the questions growing. Could there really be a planet we missed? One that orbits so slowly it takes 10,000 or even 20,000 years to circle the sun. One that might be tilted 30 degrees from our view, never crossing the ecliptic, never giving us a proper look. Some researchers remain skeptical. They argue the evidence could be coincidence, that the clustering is an illusion caused by small sample size, that our telescopes are only finding objects in certain places, creating patterns that are not really there. Others are convinced. They continue to search night after night, scanning patches of sky with wide-field telescopes, looking not for light but for movement, for the slow drift of a dim world lost in the cold. If we find it, it would change everything. It would mean the solar system is not done, that there is more to our family of worlds, that for all our science and sensors, something massive has remained hidden in the dark, and if we never find it, then something else is happening. Some force we do not yet understand is shaping the edge of the solar system. It might not be a planet, it might be something stranger, a distortion in gravity, a ripple in dark matter, a flaw in our models that opens a deeper mystery. Whatever it is pulling, not with sound, not with light, but with presence. Something out there is rearranging the orbits of worlds we barely know, something vast, something unseen. We are used to thinking of space as distant but visible. Stars shine, planets reflect, comets leave trails. But this is different. This is a silence with weight, and it is still waiting to be named. It came from a place colder than memory, slower than time, a fragile visitor long before it ever reached us, drifting through space for billions of years, untouched, unchanged. And when it finally came close enough to see, it did not shine like the planets or glow like the stars. It shimmered, softly, like frost on an old window. We called it 67P's a strange name for something so ancient. A number, a few letters, a footnote in a star catalogue, but it carried more history than most worlds ever will. This comet was chosen for a mission, one that took 10 years to reach it. A spacecraft called Rosetta followed it across the void, matching its orbit, inching closer, waiting for the moment to touch something that had never been touched. And then, for the first time in human history, we landed on a comet. The lander's name was Philae. It bounced across the surface twice before coming to rest in shadow. But even as its batteries faded, it sent back something more valuable than light. It showed us what comets really are. Not solid chunks of rock, but soft, crumbly, delicate, more snow than stone. Their surfaces are porous, almost like powder, barely holding together under their own weight. Comets are survivors from the beginning, but they are also falling apart. Every pass around the sun melts them, reshapes them. They do not last. That is what makes them precious. 67P is full of cavities and cliffs, frozen jets and sudden outbursts. As it gets closer to the sun, its surface cracks and releases gas, not with fire, but with breath. The gases carry with them dust, ice, and something more. Traces of carbon, traces of organic compounds, the ingredients of life. We used to wonder if comets brought water to Earth, if their crashes seeded our planet with what would become oceans. Now, some believe they may have brought more. The seeds of chemistry itself. Tiny molecules too simple to live but too complex to ignore. The pieces of something waiting to begin, and yet these travellers come from a place where life should not exist. The Oort cloud, the Kuiper belt, vast stretches of space where sunlight is a rumour and time moves like ice. Comets wait there for millions of years undisturbed. Then something nudges them. Gravity, collision, a passing star, and then they fall inward. When they do, they tell us things nothing else can. They are older than Earth, older than the Moon. Their cores remember what the solar system was before it had planets, before orbits were stable, before light settled into stars. And as they fall, they leave trails. Tails that stretch for millions of kilometres, leaving behind them like old photographs burning in wind. These tales are not just beautiful, they are maps of history. Written in motion and light. When we see a comet in the sky, we are seeing movement that began long before humans stood upright. And we are seeing a future, because when a comet passes once, it may not come back for 10,000 years, or ever. Rosetta followed 67P as it neared the sun, then flew beside it as it moved away. It watched it fade, watched the gases slow, watched the surface quiet again. And then, like a companion walking an old friend home, Rosetta shut down. It ended its journey not with a crash, but a gentle fall, resting forever on the comet's side. Together they drift now, no longer alone. There is something poetic about this, that we sent a machine across half the solar system just to touch something soft, to listen, to gather dust from the past and let it fall through our fingers. Comets are not planets. They do not orbit neatly. They are not part of our clockwork system. They pass through like stories, quick, glowing, full of silence and wonder. And then they leave. But when they do, they leave questions. What else do they carry? What else waits inside a billion-year-old shell? If they hold the ingredients of life, then how many more are out there? Unvisited, unlit, unknown. Maybe they are not just leftovers. Maybe they are messengers. Fleeting, cold and beautiful, but always in motion. We are taught that volcanoes are fire, heat, molten stone pouring from deep within the earth. But out there, far beyond the warmth of our sun, volcanoes are something else entirely. They do not burn, they freeze. There are places in our solar system where eruptions are made not of lava, but of ice. It begins with Enceladus, a small moon of Saturn, not even 500 kilometers wide. From the outside it seems quiet, smooth, white, pale like snow packed over centuries. But something stirs beneath, something moves. At its south pole we saw long cracks etched into the ice. We name them tiger stripes, and from them, fountains erupted. Plumes of water vapour, ammonia and ice shot hundreds of kilometres into space, silent jets from a hidden ocean deep below. These plumes feed Saturn's faintest ring. Over time, the moon gives away parts of itself, grain by grain, until a part of it floats forever around its planet. This is cryovolcanism, where the crust is ice, the magma is water. Supercooled liquid, warmed just enough by tidal flexing, a slow pull from the gravity of Saturn that kneads the moon's insides like soft clay. Enceladus is not alone. Triton, the strange backward moon of Neptune, shows similar signs. It hisses faint plumes from beneath its surface, nitrogen, not water, rising like wisps into a nearly invisible sky. Its surface is patterned with ridges and pits, as if something beneath had pressed upward and frozen in mid-breath. Even Pluto, that distant loner, may have its own frozen volcanoes. Not glowing cones of fire, but wide, sloping mounds that rise like scars. Scientists believe they may once have erupted soft, slushy ice, a kind of geological sigh that reshaped the landscape quietly in the dark. These ice volcanoes tell us something strange. That heat is not always fire. That pressure, motion, and chemistry can carve and reshape worlds in silence. That even in the coldest corners of the solar system there is movement, there is change, and beneath that ice maybe there is something more. Some of these moons have subsurface oceans, not lakes. Oceans, hidden beneath kilometres of crust, trapped under pressure, warmed by gravity alone. They may be salt water, or they may be something stranger, ammonia, methane, water mixed with compounds we barely understand, but they are liquid, flowing, alive in their own way. Every eruption, every jet, every frozen plume we see is a signal, a whisper from below. These volcanoes are not just explosions, they are openings, breaths, messages sent upward into space, and they change how we see geology. Until now we thought volcanoes needed planets, rocky bodies, thick mantles of heat, but here on tiny moons of gas giants we find another version. Soft, cold, but just as powerful. They shape landscapes, they carve new terrain, they tell of hidden oceans and unseen forces. What else do they hold? If an ocean can exist beneath ice, could something live in it? If vents open the surface, could organic molecules escape? Could they evolve? Could they survive in the warmth of cracks and pressure in the dark without ever seeing light? We do not know, but we have seen the trails, we have watched the plumes, we have tasted the dust. Enceladus, in particular, sent its particles out into space, and a spacecraft flew through them. Cassini, brushing past the moon's eruption, caught hints of salt, hydrogen, and simple molecules, things that, on Earth, mark the edges of life. It does not prove life exists, but it tells us where to look, and it reminds us that volcanoes, even ice volcanoes, are more than just vents. They are bridges, between inside and outside, between past and future, between what we see and what we still imagine. In this cold, far place, fire takes the shape of silence. Eruptions leave no burn, only snow, and somehow that makes them even more haunting. Breathe in, that air. It has a history, not just of this planet, or even of the trees that gave it shape, but of something older, something deeper, something that burned long before Earth was born. Every atom in your body, the iron in your blood, the calcium in your bones, the carbon in your breath, came from stars. Not just any stars, dying stars, stars that lived, burned, collapsed, and exploded across the galaxy. Supernovae. When a massive star dies, it does not go quietly, it bursts outward, sending shockwaves through the fabric of space. In that moment, under extreme pressure and unimaginable heat, heavy elements are born: iron, gold, uranium, and all the building blocks of life. Then, those elements scatter, they drift, they travel across light years, carried on solar winds and cosmic dust trails, until they find new homes. One day they gathered here, in this corner of the Milky Way where a new star was forming. Our sun, and the leftovers, the grains, the dust, the fragments of long-dead giants began to stick together. Gravity pulled them close, they formed rocks, then planets. One of those planets had water, an atmosphere. Eventually it had you. You're not just made of stardust. You're made of memory, of ancient fire, of lives and deaths you never saw. The universe did not just give you a home, it built you from its own broken pieces. This is not poetry, it is science. When astronomers look at the composition of stars and galaxies, they can trace the origins of each element. Hydrogen, that came from the Big Bang. Helium too. But everything else, born in the heart of stars. There is a deep intimacy to that fact. We often feel small when we think of space, the distances, the scale, the emptiness. But this changes something. You are not separate from the universe. You are not a visitor here. You are the universe. Thinking, breathing, feeling. When you touch your skin, you touch the past. When you speak, you move atoms that once floated through nebulae. When you fall in love, a part of the cosmos feels it, because that part is you. And this does not end with your body. The food you eat, the air you inhale, the water that flows through your veins, all of it is made from elements that were once inside stars. Every tree, every stone, every drop of rain. All of it came from explosions scattered across space and time. We are all made of the same dust. This connection is not just poetic, it is physical. You carry the same carbon atoms as a comet, the same iron as a meteorite, the same oxygen as the ice on Europa. It gives new meaning to everything we do. When we look at Saturn's rings or listen to the sun's vibrations, we are not watching strangers, we are watching family. The cosmos is not above us, it is within us, and maybe, just maybe, that is why we look up. Maybe that strange ache we feel when we see the night sky is not fear. Maybe it is recognition, a kind of homesickness, the soul remembering where it came from. Because long before you were born, you were there, floating through space, waiting to become someone. We think of it as fixed, the planets, their paths, the slow perfect clockwork of the solar system, but it is not fixed. It only looks that way, for now. Everything in space moves, but more than that, everything changes. Our Earth spins, it circles the sun. The moon drifts a little farther each year, slowly escaping us inch by inch. In 100 million years, it will no longer cause total eclipses. It will be too far, too small in our sky. That beautiful shadow play will vanish from the future. Mars pulls slightly at Earth's orbit. Jupiter nudges comets and asteroids. Neptune tugs gently at the outer dust. Each planet whispers its gravity into the others, shifting things we cannot see, not in a lifetime, not even in 10. But over eons, the system warps. Simulations tell us something haunting. Given enough time, chaos wins. Mercury, the small planet closest to the Sun, wobbles slightly. Its path is just unstable enough that in some far future it could crash into Venus, or be thrown into the Sun, or out into the dark, leaving its orbit behind forever. It will not happen soon, but it could. And that possibility changes how we think about stillness. We are taught to believe that orbits are safe, that they repeat, that they last, but they don't. Not forever. Earth itself is slowing down. Our days are growing longer, by just a fraction of a second every century. One day, millions of years from now, a single day will last 25 hours, then more. Time stretches even here. Even the sun, that warm, steady presence, is not unchanging. Its light shifts, its gravity pulls tighter and looser, it will grow hotter, then larger, then one day it will swell beyond Mars, swallow Mercury, burn Venus, strip Earth bare. Our solar system will not survive that, but even before that fire, other dangers wait. Rogue stars passing near could disturb orbits. The slightest nudge could tip a planet just enough to break the harmony. It has happened before. Some think our moon came from a massive collision. That Earth once had a sister world. Gone now. Blended into us. or maybe into dust. The stability we feel is borrowed. It was bought with collisions, with losses we do not remember, and someday it will end. This is not meant to frighten, only to remind us that permanence is an illusion, that the beauty of this moment, with Earth here, and the moon above us, and Jupiter glowing softly in the night sky, is temporary. Not broken, not flawed, just brief. Everything you know is part of a dance that cannot last. And maybe because of that, it matters more. If you were floating above the Earth looking down, what direction would that be? Down toward the clouds, or up toward the stars? In space there is no up, no down, no left, no right. These are human ideas, comfortable ideas, but space does not share them. The solar system has no top, no bottom. Planets orbit in a flat plane, yes, but even that is just our way of seeing it. Spin the camera, tilt your view. Suddenly everything looks upside down. The galaxy itself is a whirl of stars, curved and warped. Some solar systems lie tilted, others spin backward. Some planets roll sideways, like Uranus. Some moons orbit in reverse. Direction is just comparison. Even time feels slippery out here. A comet might spend millions of years in cold silence, only to scream past the sun in a matter of days. What was forward becomes behind, what was still becomes fast. The rules bend, not because they are broken, but because they were never written for us. Our rockets launch up from Earth, but once they're free, there is no sky, no ceiling, just motion. Everything is motion. That is the only truth space keeps. Your body has a front and a back, but an asteroid tumbling through the Kuiper belt does not. It spins without meaning, without orientation, a thing just existing, moving because something long ago pushed it. When we send probes to other planets, we still program them with what we call attitude control. Pitch, yaw, roll. These terms come from aircraft, boats, human machines built in a world with gravity and sky. Out here, they're just math. Satellites can orbit Earth sideways. Telescopes in deep space can float in any angle. They don't know which way is up, and they don't care. They only know where they must look. Galaxies spin, some clockwise, some not. And from another place, from some distant corner of the universe, even our Milky Way might appear sideways, or tilted, or inverted. Perspective decides everything, but the cosmos never promised us a fixed view. Even constellations, the pictures we've drawn in stars, are illusions. They only form from where we stand, move to another star system, and Orion breaks apart. The Big Dipper fades. Nothing holds still when distance bends light. So what does that mean for us? We are beings who search for patterns, who want maps. We crave direction, not just in space but in life. We say, I feel lost, or I'm going the wrong way. But those ideas come from a world where north is a thing, where compasses work. Space does not share that certainty, it only moves. And maybe that's the lesson, that we were never meant to find one perfect direction, only to move, to explore, to shift as the stars do. There is no up in space, no line we must follow, no axis to climb. Just you drifting, choosing, through a universe that spins without end. They never told us the solar system had tails, not in school, not in bedtime stories, but it does. Long, drifting, unseen tails, trailing behind us like ghosted threads unravelling in the wind. Our sun is not standing still. It moves quietly through the galaxy, around the centre of the Milky Way, faster than we can. And because it moves, everything it carries, the planets, the comets, the light, drags a kind of wake behind it. This wake is called the heliotail. It is not fire, not stardust, not anything we can see with our eyes. It is made of wind, solar wind, a storm of charged particles that the sun breathes out in every direction, every second for billions of years. It stretches far beyond Pluto, beyond the Kuiper belt, and then it curves to pulled, shaped, stretched into something long and narrow, something strange. At the front, there is pressure. The sun pushes against the thin matter of interstellar space, and space pushes back. That place where they collide is called the bow shock, like a wave building in front of a boat. Behind us there is the tail, soft, warped, invisible. But it is there. We are inside a bubble, and that bubble leaves a mark. This bubble is the heliosphere. It holds us. It protects us. It whispers the sun's boundary, how far its warmth, its wind, its memory can reach. And even though we cannot see it, we are inside it, like breath held under water, not knowing how close the surface truly is. The tail stretches for billions of miles. It is not symmetrical. It flickers. It bends with magnetic fields, bends with time. There are ripples in it, strange folds and waves that we do not yet understand. Some scientists believe there are folds like ribbons or curtains moving at the edge of the heliotail. Others think it may twist like a comet blown by some hidden breeze. This tail is not just a structure, it is a record. Everything the sun has touched, every flare, every gust of its breath gets written into this shape. It is history made of wind, a long, invisible map of the sun's motion through time, and we are leaving fingerprints behind us. Every hour, every orbit, every flare the sun has ever launched is out there somewhere, still moving, still carried by this ancient breeze. And when future explorers, centuries from now, cross that path, they may find it. A thin trace of us, caught in the wind, the memory of a living star long after it stops shining. Voyager 1 is already beyond the front of the bubble. It passed the bow shock and entered the space between stars, but even there the echo of our sun's tail continues. Even there Voyager listens. It hears the slow hum of particles hitting particles like rain against glass, from millions of miles away. Some say the tail is narrow, others say it is wide, some say it flickers like a flame, others think it fades like fog. We do not yet know. We have never turned back far enough to see it. All our instruments face forward. All our eyes are looking ahead. But something behind us is still unravelling, still telling the story of where we have been. The heliotail moves with the galaxy, and it moves us with it. But we do not feel it. We do not see it. We live inside it without knowing. Like fish in a current, we do not notice the river that carries us, only the shimmer of light at the surface and the things that drift beside us. If you could stand still, impossibly still in space and wait for the solar system to pass you, you would see it. A pale light growing brighter, then planets in their slow, perfect rhythm, then the wind thick with energy, then the flicker, the tail drawn out like a memory being pulled away from the present. It is not made of sound, but if it were, it would be the softest echo, the kind you feel in your chest before you hear it in your ears, a kind of song left behind by motion, a soft note that trails the melody long after the instrument has moved on. Sometimes I wonder if alien civilizations ever saw our tail, long before we sent probes, long before Earth had names. Did someone see it shimmer once? A faint pulse in the distance, a sign of something living, moving, turning through the dark. And if they did, what did they think? Did they wonder what kind of star throws wind so far? Did they imagine the lives that must orbit inside it, wondering, watching, reaching? We think of our solar system as a thing, a system, a place of orbits, masses, numbers, but maybe it is also a trail, a wake, a shape made by passage, not just of planets, but of time, not just of motion, but of memory. Every second the sun sends more of itself outward. Some of it hits planets, some of it escapes, some of it will never touch anything at all, just drift, forever. But drift where? Space is not still. It shifts, it twists, it remembers in loops and currents. The tail we leave behind might not last forever. It might bend into something else, It might vanish into dust. It might one day crash into another star's tail and mix like rivers meeting in the sea. But right now, it is there, following, trailing, carrying our warmth into the places we have never seen. And maybe, just maybe, if you could go far enough, if you could float outside the bubble and look back, you would see it. A thread of gold in the dark, a whisper of where we have been, a trace of what we are. Not just a solar system spinning in place, but something moving, marking the stars, and leaving behind a signature. It came without warning, a shape, a shadow, a traveller with no name. No one saw it coming until it was almost gone, and even then we barely understood what we were looking at. Oumuamua, the first known visitor from another star. Not from our solar system, not from anywhere nearby. It came fast, it came alone, and it did not belong. It entered from the direction of Lyra, moving faster than anything we had ever seen pass so close to the sun. At first we thought it was a comet, but it had no tail, no glow, no signs of gas or dust. Then we called it an asteroid. But its path did not match anything we knew. It accelerated as slightly, strangely as it left. Just enough to confuse us, just enough to remind us that this was not ours. It was small, no more than a few hundred meters long, but long is the right word, because it was not round. It was stretched and oddly, sharply. Some said it looked like a cigar. Others imagined a needle, long and thin, tumbling end over end as it spun. No light of its own, just a glimmer, caught and reflected from the sun it passed. Telescopes tried to follow, but it was too quick, too faint. It was already gone before we knew how rare it was. We only caught it in memory, in motion. A blurred message from far away passed through our skies like a sigh. The name Oumuamua means a messenger from afar arriving first, a word from Hawaiian, chosen with care, because that is what it was, not just a rock, not just a body, but the first we have ever seen from beyond. And we do not know what it was. There were no gases released, no ice warming off its surface, yet it moved like something pushed, as if something unseen had nudged it slightly faster. Radiation pressure? Hollow structure? Something else? No answer felt right. No explanation satisfied everyone. The mystery lingered. Some scientists whispered, what if it was not natural? What if it was a probe, a remnant of something made, not born? The shape was odd. The movement was odder. There was no signal, no control. But then again, we were not listening until too late. Most scientists still believe it was natural. A fragment, a shard, broken from something long ago, tossed from another solar system in some ancient collision. Drifted for millions, maybe billions of years, alone, silent. Then by chance passed through ours. But chance is a strange thing in space, because not long after Oumuamua, another visitor came, Borisov. A true comet this time, glowing, faint tail, classic in shape but still alien in origin. It came faster than expected, burned bright, left just as quickly. Another sign that interstellar objects may not be rare, just unseen. Now we watch more carefully. We know what to look for, and we wait. Because there could be more. Some may be small, lost among the stars. Some may never pass close enough to be seen. But now we know they exist. The universe does not keep its stories hidden forever. Sometimes they pass close enough to touch. Oumuamua did not stop, did not turn, it did not respond. But it made us look up. It made us wonder. And it made us ask a question we had not asked in a long time. What else is out there, moving between the stars? Not planets, not moons, not the giants we know, but drifters, wanderers, fragments of other suns, shaped by forces we will never see, pulled from places we will never reach, flying through the dark and unnoticed until one day they brush past the light again. And in that moment we see them, and for just a breath we are no longer alone. They remind us that we are not the centre, not even close. They remind us that other stars have their own stories, their own storms, their own collisions and dreams and dust. We are just one sky among billions, and now pieces of those other skies are passing through ours. Oumuamua may never come back. It may fly forever, unbothered, unknown. Or it may break apart quietly somewhere beyond our sight. But in its brief visit it left a mark. Not a physical one, but something deeper, something soft. A question pressed into the quiet part of our thoughts. Was it watching? Was it a relic? Was it alone? Or are there others right now on their way? There is a silence between stars, but it is not empty. Not anymore. Now we know to listen. One day the sun will fade. Not soon, not tomorrow, but eventually. The great engine at the centre of our solar system will run out of fuel. The light we take for granted, the warmth that built everything we know, will begin to change. It will grow larger, redder, angrier. The sun will swell into a red giant, devouring the inner planets. Mercury will vanish, Venus too, and Earth will burn, the oceans will boil, the sky will fall, and all that ever lived here will become ash. But even that is not the end. The outer planets may survive the swelling fire. They will drift into cold. Jupiter, Saturn, Uranus, Neptune. They will circle a fading ember, dim and silent. The sun will shrink, the light will go out, and what remains will be a white dwarf, a cinder star, a ghost of what once was. No more solar flares, no more seasons, no more dawn. But out there, far beyond the reach of that dying light, something will still be moving. Voyager, still drifting and still carrying our hellos, our music, our whispers, still pulsing with the last bits of power left in its heart. And when even that fades, the spacecraft will continue, not as a signal, but as a message in shape and metal. A tiny monument to our time in the sun. Maybe someday someone will find it, or maybe no one will, but it will be there, long after Earth is gone, long after the planets have scattered, long after the solar system is a forgotten swirl of dust in a quiet sky. And that is the strange comfort of it all, because everything ends, but nothing is truly lost. The particles that made Earth, made you, made everything, they will not disappear. They will move. They will merge with something else, maybe form a star, maybe a planet, maybe a body warm with life again. The universe does not throw anything away. It remembers in silence. Even this story. Somewhere, long after the sun has faded, a single atom from your body might burn again inside a newborn star. The elements in your bones might float through space until they land on a world that has never heard of Earth. And in that world, a being might breathe you in, not knowing your name, your language, or your sky, but carrying a piece of you all the same. Everything you are continues. That is the poetry of the universe, not in the grand explosions or the dazzling lights, but in the quiet after, in the long trail of memory that dust leaves behind. This is how the solar system ends, not with a crash, not with a scream, but with a gentle glowing pause. It will not be sudden, it will not be loud, but it will be complete. The warmth will fade, the music will stop, and only motion will remain. Stars will be born and die, galaxies will shift. And in that endless dance, what was once our home will dissolve quietly, peacefully, and into the fabric of everything else. But the story will still be here, etched in the atoms, written in the orbits, whispered in the space between stars. The solar system is a moment in cosmic time, but what a moment it was. If these words stayed with you, if this journey touched something quiet in you, then feel free to like, subscribe, or leave a comment below.